Okay, so we have this problem here. It's a definite integral, the lower limit 0, upper limit 3, and of course with respect to x. So let's get right to business. So just looking at the integral, we know that it doesn't fit in directly. It's not in standard form. We have to apply we can apply a U substitution here. But ordinarily, if the U substitution were to come easy, the 1 plus x that's in the root, the derivative of the 1 plus x should be able to eliminate the numerator, but that's not the case here. So in this case, our u will now be the whole root 1 plus x. So let's start from there. U will now be equal to root 1 plus x. And then to eliminate this root, we'll have to square both sides. Now this 2 cancels out the root. We now have u squared equal to just 1 plus x. And now that the u is now fully involved, the u is the dependent variable here, we will now differentiate implicitly. So differentiating u squared, I have 2u, and of course the u dx equal to, then here derivative of 1 is just 0, derivative of x is 1, and I can divide through by 2u. I will then have the u dx equal to 1 over 2u. And then in this case, I want to make my dx the subject of this formula so that I can replace its value with the dx here. So that means I will have to treat the u dx as a fraction. That means I can cross multiply here. Then I have dx times 1 is dx equal to, then 2u times the u gives me 2u du. So finally my dx is now the subject of the formula, and then I can replace this dx with 2u du, and then I'll rewrite the whole integral. So rewriting this, and of course I can replace my root 1 plus x with u, because I started with making u equals the whole root 1 plus x. So I will now have integral, fix the boundaries, then I have x squared plus 2x over u, then I have 2u du. Then notice that this u and this u can cancel out. I'm left with x squared plus 2x, then du. But this doesn't make sense because now I have to differentiate with respect to u, and I have the variables x here. So let me now rewrite this one, or let me go back to this and then make x the subject here, and then replace the values here with my variables x. So rewriting this one I have, let me come right to this one here, this equation. So I have u squared equals 1 plus x. Then, and I have, if I should make x the subject, I have u squared minus 1 equals x. So x equals to u squared minus 1. So anywhere there's x, I'll fix u squared minus 1 so that it will blend in with what we are integrating with respect to, which is u. We can't have x and then expect to differentiate with respect to u in this case. So let's do that. So anywhere there's x, I will fix my u squared minus 1. So rewriting that, I have integration. Again, fix your limits. Then here I have u squared minus 1 all squared, because of course there's a square here, plus 2 bracket u squared minus 1 close bracket. Then with respect to u, now it makes sense. I have my u and I have u everywhere all through. So now it makes sense. Oh, I forgot my 2. Fix that one carefully here. So that's 2. So the 2 is still there. Then we can, okay, let me expand this. If you expand this, you now have the integral. Fix the boundaries. This one now becomes, if you expand this one, that's u squared minus 1 times u squared minus 1. You're going to get u raised to the power 4 minus 2u squared plus 1. And then this one, if you open the bracket, you get plus 2u squared minus 2, and of course everything times this 2 here, and we have our the u still with respect to u, and then we can now we can cancel out minus 2u squared and plus 2u squared. They're all going out, and then we'll have here we'll have, okay, so we still have the integral. Fix our boundaries. We now have these two still there, be careful with it, 2 bracket, then we have our u raised to the power 4, and then we still have minus 2 plus 1, so minus 2 plus 1 is minus 1, then close your brackets. We still have our the u, then we have we can open the bracket or pull the 2 out, anyhow you want to do it. So we now have the integral, we have our limits, we now have 2 u raised to the power 4 minus 2. If you open the bracket with this, 2 times u raised to the power 4 is 2u raised to the power 4, then 2 plus times minus is minus, 2 times 1 is 2, and we have our the u. We can now, it is now in standard form, we can now integrate confidently. Remember, here we're adding 1 to the power for the variable, and then we are bringing that 4 plus 1 down here again, and here it is like you have u raised to the power 0, and if you add 1, you add the 0 plus 1 down. So here we now have 2u raised to the power 5 over 5, and minus, this is just 2u, because 2u raised to the power 1, this will not be 1 over 1, so this is just 2u, and we now have our boundaries as 3 and 0. So fixing back our value for u, remember we made u to be root 1 plus x. I'll bring that value back. So anywhere there's u, I'm putting root 1 plus x there. So I have 2 root 1 plus x all raised to the power 5 over 5 minus 2 bracket root 1 plus x. Then we still have our boundaries, but let's be careful here now. For the boundaries, to get the exact value, to evaluate the integral with respect to these boundaries given, so I will first fix 3 into the values of x, and then I'll evaluate, and then later I'll fix 0, and then I'll make my subtraction. So let me fix 3 first of all. So fixing 3, so that'll be 2, fixing 3 for x, that'll be 2 bracket root 1 plus 3 raised to the power 5 over 5 minus 2 bracket root 1 plus 3, then close bracket. Then this will now be 2, this is 1 plus 3 is 4, and the square root of 4 is 2. They will now have 2 raised to the power 5. We still have over 5 minus 1 plus 3 is 4. Square root of 4 again is 2. 2 times 2 we have 4. And then if you further simplify, you are getting this is 32. 2 raised to the power 5 is 32 times 2, that will be 64 over 5 minus 4 is what you get. So let's leave it at that. Then again, now for the 0, because we are done with the 3, if you are fixing 0 for x here, now we are going to get 2 open bracket root 1 plus 0 raised to the power 5 over 5 minus 2 bracket 1 plus 0 close bracket, and 1 plus 0 is 1. Square root of 1 is still 1. 1 raised to the power 5 still 1. Then 2 times 1 is 2 over 5 minus, then we have 1 plus 0 is 1. Square root of 1 is 1 times 2, you have 2. So now we can now make us subtraction. So we now have 64 over 5 minus 4 then minus 2 over 5 minus 2. If you solve up the fraction, you're going to get 52 over 5 as our final result if you evaluate this. So that's it.